Hey everybody. We've been doing a lot of work with linear equations lately in class, but linear equations can't be used to represent every type of situation. Sometimes you might need a different type of equation. Tonight we're going to look at how to identify linear relationships and when we recognize one, to find the equation that represents it. The main thing to keep in mind when dealing with linear equations is that linear equations always have a constant rate of change, right? That's what makes it a straight line. So when we're looking at an example like this one here, we have our x values, we have our y values. If this relationship has a constant rate of change, then we know that it's a linear equation. So let's take a look at what's going on with our x values. Right? Our x value here is from -2 to -1. That's increasing by 1, right? Plus 1. -1 to 0, that's plus 1. 0 to 1, that's plus 1. 1 to 2 is plus 1, and 2 to 3 is plus 1. And then for our y values, we have plus 3 to get from -5 to -2. -2 to 1 is plus 3. 1 to 4 is plus 3. 4 to 7 is plus 3, and 7 to 10 is plus 3, right? So for each of these jumps here, right, from this point to this point, the rate of change is 3 over 1, right? Because we have to do delta y over delta x, change in y over change in x. And we get 3 over 1 for that first point. The second point is also 3 over 1, or that second jump. Going from the third to the fourth point is 3 over 1, 3 over 1, and 3 over 1, right? These all have the same rate of change, which is 3. So now we can write a linear equation to represent this situation. We can do this a couple of different ways. We can use point-slope form or slope-intercept form. I already know the slope. I need that for either form of the equation. And I see this point right here, 0, 1, which is the y-intercept. So that, to me, says that slope-intercept I can set up pretty easily, right, if I use slope-intercept form. Now, I could use point-slope form, still get an equivalent equation. That's fine, too. So you can really do it either way here. So slope-intercept form says that y equals mx plus b, and when I substitute m and b, I get y equals 3x plus 1. I get 3 from my slope right here, and I get 1 from my y-intercept. So that's my equation for this situation. Let's take a look at another example. Remember, if a relationship is going to be represented by a linear equation, it has to have a constant rate of change, or a constant slope. So let's find the change in x and the change in y here for each jump, and then we can tell whether or not it's linear. So my x values are all changing by 1 again. Plus 1, plus 1, plus 1, plus 1. And my y values now, it's going from 9 to 5, my first one, so that's minus 4. 5 to 2, that's minus 3. That's going to be minus 3, minus 4, and minus 3. Now, when I write my slopes, remember it's change in y over change in x, so I have -4 over 1 for my first one. I have -3 over 1, -3 over 1, -4 over 1, and -3 over 1. Now, these are not all the same. Because these are not all the same, this cannot be a linear relationship. Even though, as my x values increase, my y values decrease, it's not perfectly linear. So this is not a linear relationship. The table shows the cost of visiting a working ranch for 1 day and night for different numbers of people. Can the situation be modeled by a linear equation? Explain. If possible, write an equation that gives the cost as a function of the number of people in the group. So we want to find the slope, the change in y, over the change in x between each point here to see that they're all on the same line. The number of people is going to determine the cost. So the number of people are the input, and the cost is the output. So let's find what our x values are increasing by. So 4 to 6, that's plus 2. 6 to 8 is plus 2. 8 to 10 is plus 2. And 10 to 12 is plus 2. Now let's take a look at our y's. 250 to 350, that's plus 100. 350, 450 is plus 100. 450 to 550 is plus 100. And 550 to 650 is plus 100. So when I look at my change in y over change in x for each of these, I have 100 over 2, 100 over 2, 100 over 2, and 100 over 2. And if I simplify all of these, they're all equal. If I simplify them, I get 50. So 50 is my slope. Since they all have the same slope between each pair of points, we can write an equation for this, a linear equation. Remember, we can use any form. We can use slope-intercept or point-slope. In this case, I don't have my y-intercept, so I'll use point-slope here. I don't have to use point-slope. I could use slope-intercept, but let's get some practice with this. Remember, point-slope is y minus y1 equals the slope times x minus x1. And we just need to pick a point. Let's pick this lowest one, 4 and 250. So my y value here is y minus 250, which equals 50, which is a slope, times x minus 4. And there I have my linear equation. I could put it in slope-intercept form if I want, but it didn't say that we need to do that. So I'm just going to leave it like that, and we can be done. So you guys can go ahead and finish up your notes, submit them through Canvas, and I will see you all tomorrow. Have a good night.